All right, so we're going to put together polygons and the work we've been doing with distance formula, midpoint formula, and slope formula. So there's nothing new, but make sure that you guys have these formulas written down. If you don't have them memorized on that by now, you should be really close. All right, so we're going to create a triangle with these vertices. My suggestion to you, and since I grade your papers, I definitely would take my suggestion, is to put the coordinate and the point on your graph. So when we have a over 0 up 1, go ahead and label it a 0 1, b 4 4, 4, and c 7 0. Okay, so this creates a nice little triangle. Go ahead and draw that on your paper. And we want to know if it's scalene, isosceles, or equilateral. That means 3 sides different, 2 sides same, or all 3 sides are the same. So at the end of the day, we're going to be doing the distance formula 3 times. So we're going to distance formula. And I write myself a little list here so I can keep track between A and B, between B and C, and between A and C. And we're going to compare those 3 distance formula results. So the first one is the distance between A and B. So that is our x's subtracted squared plus our y's subtracted squared. We get 4 minus 0 is 4. 4 squared is 16. 4 minus 1 is 3. 3 squared is 9. 16 plus 9 is 25. And the square root of 25 is 5. So I'm going to go ahead and put that on my picture so I remember. AB is 5. BC, we're going to take our x's and subtract them. So that would be 7 minus 4. And then our y's and subtract them, that would be 0 minus 4 squared. So 7 minus 4 is 3, and 3 squared is 9. Negative 4, 0 minus 4 is negative 4, and negative 4 squared is 16. So 9 plus 6 is 25, and the square root of 25 is 5. That goes on BC. The last one we have to do, and if it's 5, we are definitely have 2 of the same sides. If AC is 5, then we have 3 of the same sides, but let's go ahead and check that. So for AC, we are going to subtract the x's, so that's 7 minus 0 squared, and subtract the 1, 0 minus 1 squared. And we get 7 squared, which is 49, and negative 1 squared, which is 1. And that's equal to the square root of 50, which is not 5, and there's not even any reason to calculate that out. So in this case, we have an isosceles triangle. Yay! Make sure you pause this if you need to write down the rest of the distance formulas. Okay, so let's look at example 2. So we're going to see if our quadrilateral is a rhombus. Our hint is that the slopes of the diagonals. If it's a rhombus, then the diagonals are perpendicular, and then the slopes are negative reciprocals. So let's go ahead and put our coordinates down. Negative 2, 0 is A. 0, 4 is B. 4, 5 is C. And 4, 5, hold on just a second. Alrighty, so we have a little bit of typo on your paper. So go ahead and change the C to 2, 2 and the D to 4, 6. And D is 4, 6. Let's go ahead and draw that out so we can kind of see what that shape looks like. And if we're testing to see if it's a parallelogram, then the diagonals, or if it's a rhombus, we're going to see if those diagonals make a nice 90-degree angle. So we are going to find the slope of BC and the slope of AD. And I write this down so that I can keep track. If I'm not keeping track, then it's easy to get lost in the flow of stuff. So we're going to use the slope formula, y2 minus y1 over x2 minus x1. So let's have C be x2, y2, and B be x1, y1. So I can see I got 2 minus 4 for my y2 minus y1 and 2 minus 0. I get negative 2 on the top and 2 on the bottom. That gives me a slope of negative 1. If AD is perpendicular, then my slope is going to be the negative reciprocal of negative 1. So let's test that. AD, so let's have D be y2 and y1. Sorry, x2 and y2. And let's have A be x1 and y1. If I don't label it, I get all mixed up. We get 6 minus 0 and 4 minus negative 2. 6 minus 0 is 6. 4 minus negative 2 minus the negative is plus. And the slope is 1. So since these are negative reciprocals, then we have a perpendicular line, but we are going to use the distance formula to show that to compare all of our sides. So we know that our slopes are negative reciprocal, so we've proven that the diagonals make a 90-degree angle. So now we need to show that our sides are all congruent in order for it to be a rhombus. All right, so we are going to distance formula, just in case you forgot what that was. That is the x's subtracted squared plus the y's subtracted squared. So that would be, so let me just track it. So we want to do AB, we want to do BD, and we want to do DC, and we want to do AC. Only have to do this 4 times. It's fine. Okay, so AB, the distance is going to be x2, so let's make that 0, minus x1 to the negative 2, squared, plus y2, which is the y that goes with the 0, 4, minus y1, which is 0, and squared. 0 minus a negative 2 is plus 2, and plus 2 squared is 4. 4 minus 0 is 4, and 4 squared is 16. AB is the square root of 20. I'm just going to go ahead and leave him in that format. Okay, so let's find BC in the same manner. BC is not, it would be BD. That's this distance here. So this is square root 20, AB. BD is, the x is subtracted, so let's go 4 minus 0 squared and 6 minus 4 squared. 4 minus 0 is 4, squared is 16. 6 minus 4 is 2, and 2 squared is 4. Oh, heck yeah, that equals square root of 20, so I'm 2 for 2. And then we're going to do DC. So we're going to subtract the y's, or sorry, subtract the x's. 4 minus 2 squared and 6 minus 2 squared. 4 minus 2 is 2, and 2 squared is 4. 6 minus 2 is 4, and 4 squared is 16. That is the square root of 20. Put that down there. I'm 3 for 3. Let's just, if AC pans out for us, then we know we have a rhombus. So AC, I'm going to go Y2, sorry, X2. So X2 is 2, minus X1 is negative 2. Y2 is 2, minus 0. So I got 2 minus negative 2, that's the same as 2 plus 2. And that is 4, and 4 squared is 16. Looking good. 2 minus 0 is 2, and 2 squared is 4. 16 plus 4 is 20. And last but not least, not only are my diagonals perpendicular, but all my sides are congruent. So this is a rhombus. You need to show every distance formula. You need to show that you found the slopes in order to prove it's a rhombus. Okay. Okay, so let's take a little peek at this parallelogram. It's got its vertex at one of the origins, and one side is along the x-axis. What is the coordinate of D, the point of intersection of the diagonals, and how do we know? So we know that the distance from here to here is 2a. We know that this distance from here to here is 2a plus 2b, because 2b is this little guy right here. 2a is this distance here. So our coordinate is 2a plus 2b. And we know we have a height of 2c, but that's not going to help us in this situation. Okay, so let's go ahead and look at D like it is the midpoint. So if I was to do the midpoint formula, we got x2, so that's the distance between here and here. So we have x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So this is going to be our, so 0, 0 is going to be our x1 and y1. And this is going to be our x2, and this is going to be our y2. So let's go ahead and plug those things into the formula. So our x1 is 0, and our x2 sorry, our y1, sorry, no, I had it right the first time. Our x2 is 2a plus 2b. 0 plus 2a plus 2b is 2a plus 2b, all divided by 2. 2a plus 2b divided by 2 is the same as a plus b. 0, so this is y1 and y2. 0 plus 2c is 2c, and divided by 2 is just c. So our d coordinate is a plus b. So it happens at a plus b, comma c. So that takes care of what are the coordinates of D. And we know that is the case because D is the midpoint or the intersection of the diagonals. All right, and that's our lesson for today.